COVID-19 is a novel coronavirus infectious disease caused by the severe acute respiratory syndrome coronavirus 2, or SARS-CoV-2. Since it first emerged in December 2019, there has been rapid global spread of the virus, leading to a worldwide public health crisis. One of the main challenges faced by scientists and clinicians in controlling the spread of the virus is the vast clinical variability of the disease. Clinical outcomes can vary greatly, ranging from asymptomatic infection to severe illness. Epidemiological studies have identified 3 factors that increase the risk of severe disease: being male, being elderly, and having underlying medical conditions. The COVID Human Genetic Effort is an international project that was established to understand the genetics driving the clinical outcomes of SARS-CoV-2. Specifically, researchers aimed at testing the hypothesis that previously healthy patients who developed severe COVID-19 carry genetic variants causing errors in immunity to SARS-CoV-2. What they found was that among patients with life-threatening COVID-19 pneumonia, many lacked type 1 interferons, whether it was due to a genetic mutation or an autoimmune condition. Interferons are a group of signaling proteins that are part of the innate immune system, playing a key role in the body's defense against viruses. In one study, the researchers genetically analyzed blood samples from 659 patients who had been hospitalized for life-threatening pneumonia due to SARS-CoV-2. They analyzed 13 genes involved in the toll-like receptor 3 and interferon regulatory factor 7 production of type 1 interferons and found genetic defects at 8 of the 13 genes in at least 3.5% of patients. Another study searched for neutralizing autoantibodies that act against type 1 interferons in 987 patients with life-threatening COVID-19. They found that at least 10% of patients with severe COVID-19 had these autoantibodies against type 1 interferons at the onset of disease, while those with asymptomatic infection did not. These autoantibodies attack the immune system rather than the virus itself by impairing the binding of interferons to their cellular receptors, thus disrupting activation of downstream pathways. These findings highlight the important role of type 1 interferons in the immune response to SARS-CoV-2. There is growing evidence that the disruption of type 1 interferon cellular pathway is in many cases the causes of severe COVID-19, and inborn genetic errors can explain why healthy individuals become seriously ill. Understanding these biomarkers can help predict the clinical outcomes of the virus, while also having important implications for future treatments of COVID-19.